Here, Algebra पाहिलंच नाही आपण केलं. तो डान्स चांगला केला होता का? तुम्ही सांगितले नाही बरं का मला, फोन करून सांगितले. हा आम्ही फोन केला होता, तुम्ही उजरला रे द्या. झालं ना
Third, we invoke the blessing of Goddess Saraswati, the symbol of vision, knowledge and learning. Along with this, we say our ancestors to all the leaders, create the foundation.
YouTube लिंक टाकली ग्रुपला ती पण शकते. बाहेर करा. दोन मिनिटं मला इकडे जाऊ.
थँक्यू.
YouTube लाईव्ह आणि झूम ऍप बाहेर जाऊन हे चेक करून चालू येतं. मला फक्त चेक.
And you all, I requested all the dignitaries of the time, please, will you make a prayer? Thank you once again. To formally welcome the gathering, I now invite coordinator of this conference, Vice Principal, Head of the Department of Chemistry, Dr. T.S. Savlekar, to deliver welcome address and present a brief conference overview.
Respected dignitaries on the dais, honorable members of management, respected principals, Indian speaker, member of advisory committee, esteemed colleagues, researchers, dear students, and all participants, a very good morning to one and all. On behalf of Department of Chemistry, Mahatma Gandhi India Mandir, Maharashtra State
आवाज
of
येतोय.
Right on and pharmaceutical it is my proud privilege to extend a warm and cordial welcome to all to the International Conference on Frontiers in Chemical and Material Science. We express our deep sense of gratitude to our Chief Editor, Honorable Maila Srimati Pushpa Gire, Honorable Dr. Prashant Gire, Honorable Nitai Prashant Gire, Honorable Dr. Apurva Gire, Honorable Dr. Advayama Gire,
केमिकल
Honorable Yogita Sai Apurva Gire, Honorable Dr. Sarpata Gire, Honorable Dr. B.S. Moresa, Honorable Principal Dr. B.S. Jattari, whose constant guidance and support have made this possible. We are highly honored by the gracious presence of our chief guest, Dr. Harish Adkesar, Vice President, MG Vidyamandir, Nashik. Our eminent speaker, Dr. Avinash Kumar, sir from SCU and President of the conference, our respected Principal, Dr. Subhash Nishal. I also extend my sincere thanks to our respected advisory committee, Dr. Rajesh Shinde, C.G. Ligavkar sir, U.P. Kadam sir, D.F. Shirode sir, A.P. Patel sir, Dr. Satish Thakre sir, Dr. Vishnu Advai sir, Nodal Officer Kalyan Kokle sir. We are privileged to have distinguished eminent invited speaker from across the globe, including Dr. Bhuvneshwar Chaudhary, Germany, Nicola Handa, Netherlands, Ramaswamy sir, Mauritius, Rajendra Bulaki sir, South Korea, Dr. Santosh Maske, LCL Pune, Dr. Yogesh More, LCL Pune. Their participation has greatly enriched the academic field of this conference. Excuse me, amidst pleasure and pride to welcome you all once again to this prestigious international conference. Our Department of Chemistry is established in 1959. I think the inception of this college has a rich academic and research. The PhD Research Center started in 1982, marked a significant milestone in our journey. The MSc program in physical chemistry was introduced in 1972, followed by the MSc program in organic chemistry in 2007, reflecting our continuous commitment to higher education and advanced research. Today, department has proudly produced 55 PhD holder and AMC award. Currently, 25 PhD research students are pursuing their doctoral research under the guidance of our experienced faculty members. The department has 16 sanctioned teaching faculty members. Out of these, 12 are PhD qualified and remaining 4 are actively pursuing their doctoral research. The department has clear approved PhD guides along with associate guides actively engaged in guiding quality research. Over the past 3 years, our faculty members have published 8 research papers in reputed national and international journals. ICFCMS 2016 aims to provide a global platform for the exchange of ideas, innovation, and discussion on emerging trends in chemical and material science. I sincerely thank our management, principal, IQAC coordinator, nodal officer, organizing committee, sponsors, speaker, and delegates of the wholehearted support and cooperation. I am confident that the deliberations of this conference will be fruitful, inspiring, and impactful. With these words, I once again extend a warm welcome to all and wish the department a success. Thank you. Thank you, Rush, for sharing the contents of this conference. Ladies and gentlemen, it is now privileged to introduce our
नाही,
guest
पत्रिका
and
चालू
Indian
होतो.
speaker. For that, I would like to call upon Dr. Satish Nede sir for the introduction.
चालते मग येतो 2 नंतर. हा नाही तर संध्याकाळी निवांत येतो.
Good morning to all. It's my privilege to introduce our esteemed keynote speaker, Professor Dr. Avinash Kumbarkar. Kumbarkar is a senior professor in inorganic chemistry at SPBU Pune and has been associated with the university for over 3 decades, making outstanding contributions to teaching, research, and academic leadership. He completed his MSc in 1987 and PhD in biochemical chemistry in 1993 from University of Pune. His research spans metal DNA interaction, supramolecular chemistry, metal complexes for water oxidation, and fluorescence spectroscopy. He has published 85 research papers and received over 3,600 citations with an index of 27. And has successfully guided 13 PhD scholars along with more than 100 MSc research projects. Kumbarkar has led several funded research projects supported by agencies such as DSC, CSIR, UCC, PARC, DSC, and Erasmus Plus with international collaboration in Germany and Finland. His honors include the INSA Teacher Award, SI Bronze Medal, and Vintage Job Teacher Award. He has also served as a mentor to the Indian Chemistry Olympiad team and international competition. In addition, he has held key administrative roles at the university, including chairman of BOS Chemistry, member of Academic Council, director of Central Institution Facility, and coordinator of DSC First Program. We are truly honored to have him with us today. Another resource person, esteemed speaker for the first technical session of this conference, Dr. Moresha Solomon. Sir is a distinct researcher in the field of organic synthesis and flow chemistry. Sir has completed PhD in organic chemistry from Indian Institute of Science Education and Research, Pune. His doctoral work focused on metal catalysis and metal-free transformation, pH functionalization, and sustainable synthetic methodology guided by green chemistry principles. He has impressive international research profile and has worked across leading research environments in Spain, United Kingdom, and Germany. He is the recipient of prestigious Marie Clodovsky Curie Individual Fellowship and has served as a postdoctoral fellow at Institute of Chemical Research of Catalonia in Spain. Currently, Professor is a postdoctoral researcher at Max Planck Institute of Coal Research, Germany, working under the guidance of Professor Benjamin List, Nobel laureate in Chemistry 2021. Sir has authored several high-quality publications in leading international journals and has actively presented his work at different conferences. And his research contribution reached fundamental chemistry with practical, industrial, really relevant applications.
We are honored to have him with us today at this conference. With his brief introduction, I now request Dr. Rao Sinde sir to kindly take over and proceed with the program.
Thank you so much, ma'am.
Dear participants, to honor our distinguished dignitaries on the dais for their invaluable contributions to academia and research. Now, I would like to request President of this conference, our Principal, Dr. S.N. Nikam sir, please come forward to felicitate our guest of honor, Honorable Dr. Harish Arke sir. Thank you, sir. I again request to Principal sir to felicitate today's eminent speaker, Dr. Maurice. He is from Germany. Thank you, sir. Now I request our Vice Principal, Dr. Savit sir, to felicitate Dr. Satish Thakre sir, Previous Member, Savitribai Phule Pune University, Pune. Thank you, sir. Thank you, sir. Now, again, I request Dr. Savit sir to felicitate a dynamic researcher of our institute, Dr. Vishnu Advai sir from English College. Thank you, sir. Thank you so much. Now it is my proud privilege to invite our honorable guest of honor, Dr. Harish Arke sir, to deliver a brief inaugural address and formally inaugurate ICFCMS 2026.
Dynamic principal of this college, Dr. Sivas Nikam, undergoes the leadership, academic leadership is going on for the science faculty, the vice principal, Dr. Rani Kavre, then academic supervisor, Mani Sarani, Kokni, the resource person from Germany, he belongs to that he is from Nashik only, but nowadays in Germany, that Mauritius, Saudi sir, then we was member of the Savitribai Phule Pune University, Dr. Satish Thakre, all the dignitaries and the dynamic researcher and the global researcher that Advai, all faculty members, my dear students, all the teachers, non-teaching staff, and who helped Dr. Subhash Nikam to this event and assist all the persons. So, I am very, it is a great honor
to address this prestigious international conference and to share insight on the topic that lies in heart of modern scientific and technology progress, the frontier, chemical and material science. Chemical and material science is no longer confined to laboratories alone. It is serving the future of energy, healthcare, environment, electronics, space technology, and sustainable development. I highlight emerging frontiers, the thinking throughout the further direction of this environment. Another thing that first is evaluation of chemical and material. First is evaluation and chemical material science, traditionally chemistry, focus on reaction of compound and fidelity, while the material science concentrates on structure, property relations. In the 21st era, now we are already completed more than 25 years of this 21st century, we focus on biology, then nanotechnology, data science, artificial intelligence. Another thing is that the non-material and nanotechnology, we advance, the key advance is carbon-based, metal and metal oxide, quantum dot, application, ultra-fast electronics, tractor delivery, high performance sensors, water purification, and non-metrical offer, especially mechanical train and electrical conductivity and chemical respectively, transforming the industry worldwide. Another thing, third important that we have to discuss on this seminar regarding the advanced function of material, that function materials are designed to perform specified tasks where the structural audit major categories are smart materials, self-healing materials, stimuli responding impact over that, aerospace, defense system, robotic and soft electronics, soft instrument and biometrics. These materials respond the intelligently to paper and pressure, light and electricity and management field. Then the fourth is that energy and sustainability, energy challenges represent on the most of the critical global issue and material science is central role as central area, next generation battery materials. Then that hydrogen storage, the photovoltaic and pro-physical solar cell, catalyst and green energy. The goal is that to achieve the clean, affordable and sustainable energy while reducing the carbon emission and dependence on the fossil. Then green thing. The green chemistry is transforming frontier into emitting environment impact that core principle, use of renewable raw materials, environment friendly solvent, energy efficient, waste-free synthetic, emerging trade, then the biological polymer and biomass plastic. The fifth regarding this, that is biomaterial and healthcare innovative, that the tissue engineering, drug delivery, antifungal and antiviral therapy. Seventh is that the computing material science and artificial intelligence, the further material discovery, reducing experiment cost, another conservative electrical material, then eight And 9, that the past, then the frontier and chemical material science represent the frontier woman progress itself, sustainability energy to advance the healthcare from smart city to smart explosion, material arts, silent, innovation. And as a scientist and as a researcher, our responsibility is not only to discover the new material, but to ensure contribute to give a safer, cleaner, and more equitable world. So now you are in the era of 21st. Now, one thing is that how the students nowadays, because before that, we are taking the education from Gurukul to Gurukul. We are taking the education from Gurukul to Gurukul. And another thing is that when we were the students, that was just a black book. And now we have computer and everything. So, here, again the fear, the courage is the most. In the era of discussion, courage is the most. So let me use one example of Pagari here. In the Argentine, महात्मा गांधी जवळ महात्मा गांधी जेव्हा बॅरिस्टर झाले तर त्यांनी वकिली सुरू केली लंडन. वकिली सुरू केल्यानंतर त्यांना गोपनीय सारखे आणि महात्मा गांधी घाबरत नवीनच ते बोर्डवर चढले. तर त्यावेळेस त्या जजने सांगितलं गोपनीयांना, "Ready, Mr. Gopni, change your leader. Change your leader." तर म्हणजे महात्मा गांधींनी तो धडा घेतला आणि मग ती जेल काढून टाकली आणि became the father of the nation. And another thing is that nowadays courage is known as a currency. Courage is known as a currency and brain known as a capital. Brain known as a capital. Now in last week, the FTA come in the global scenario or in the Indian market, FTA come. Free trade agreement. How is it 37 countries? From the European countries, because this was the initial start from the when our Prime Minister Manmohan Singh was there in the year of 2006. Our journey from 2006 to 2026, we were traveling to get the licenses, free trade agreement from 2006 to 2026. We got 37 countries, and in that 37 countries, 37 countries that we can exchange commodities. So now Mercedes will be cheap, chocolate will be cheap, even that wine will be cheap, but our import-export trade will be the most interesting topic. So now yesterday our honorable finance minister declared the budget. And for our higher education, and from the education, 1,39 lakh, 1 crore 39 lakh rupees they given for the education per lakh. The most is given to the primary education, secondary education, but the less part given to the higher education. So nowadays everybody thinks that, yeah, to incur the expenditure from our. So because when I discussed with Dr. Nikam and Dr. Anil Salve that what about this international conference, that whether you will get some from Pune University, that time he told me that he gives the information, none not a single rupee from the university, but that did happen. That did happen. Now we have to contribute. Cause is that in the मराठी पूर्वीच्या काळामध्ये जेव्हा राजे होते भारताला, राजे होते तेव्हा राजेशाही होती, राजे मदत करायची म्हणून सयाजीराव गायकवाड यांनी बौद्धांना शिकवलं. सयाजीराव किंवा सयाजीराव गायकवाड, पवारजी, नागजी पवार शाहू महाराज यांनी वेगवेगळ्या शिक्षण संस्था काढल्या. आपल्याला इंडिपेंडन्स आणि आपण त्यावेळेला UGC आली, सगळ्या ग्रँटेडच्या कॉलेजेस होते. पण आता राजेशाही लोकशाहीमध्ये बिलकुल नाही. आता लोक आश्रयावर आपल्याला संसार चालवायचा आहे आणि लोक आश्रयासाठी आपलं नाणं कणकणीत असलं तर लोक आपल्याकडे येतील. आणि म्हणून हे जे नो ग्रँटचं जे पीक आलेलं आहे त्या नो ग्रँटच्या आमच्या आपल्यासारख्या सक्षम शिक्षण संस्थांनी मात्र अशा पद्धतीने एवढ्या पुढाकार घेतला पाहिजे आणि बाहेरचे नो ग्रँटचे पीक कसं कमी होईल आणि आपण कसं सस्टेन होईल आणि त्याकरता आता हे मोठं इन्स्टिट्यूट our management authority or principal and everything the effort so I will use the proper quotation that effort may be failed but do not fail to make the effort on this ground. This event the 2 days international conference with the discussion along with Dr. Kumar, then Dr. Gardale, Dr. James, Jenda, Ramaswamy, Kalkule, Mauricio Chaudhary, and Yogesh More on the global level scenario concern. They will discuss each other, and from this will get the fruitful result from this international conference. So, in this word, I declare the inaugurated of the. Thank you very much. Thank you, sir. Thank you so much for inviting the gathering. I now invite our special guest, our mentor, respected Principal Dr. B.A. Jagdale sir, for sharing insights on recent developments, challenges, and future prospects in chemical and material sciences. Sir, it's over to you.
Okay, thank you, Rohit.
बोला सर.
I am audible?
Yes sir, you are audible. Yes sir.
Okay. Respected Vice President of Mahatma Gandhi Vidya Mandir, Honorable Principal Harish Hadke sir. Today's speaker Dr. Avinash Kumbar, Moreshwar Chaudhary, Principal of this college, Dr. Subhash Nikam, Vice Principal Anil Salve, our colleagues Dr. Satish Thakre sir, Member of Board of Study SPPU, and all the participants who join through online modes and offline modes. Mahatma Gandhi Vidya Mandir's Maharaja Sayajirao Arts, Science and Commerce College Autonomous is one of the oldest institutions who provide mostly education for the area from 1959. Research Center is the one of the oldest research center in Nasik districts as well as in SPPU under SPPU. And credit goes to Dr. P.S. Nikam who developed this research center, and because of the contribution of Principal S.S. Patil and then Dr. B.S. More, Ravi Karnar sir, and other principals also developed this institution research center in a good number. Number of PhDs holder from these institutions are more than, I think, MPhil and PhD more than 100. This is the achievement of these institutions. In this international conference, named as Frontiers in Chemicals and Material Science, I want to highlight some important parameters toward this sustainable and green chemistry. I'm not taking a lot of time. Within 5 minutes, I want to use all my concept. Sustainable and green chemistry nowadays very important one. Development of eco-friendly and green synthetic methodologies. all over the world are focused on this green synthetic methodologies and eco-friendly materials. Now, second important parameters is the use of renewable feedstock and bio-based raw materials. Most of the agriculture sectors and other areas also, the second important is a renewable feedstock. Waste minimization and pollution prevention is the one of the area where the chemicals and material science are most important developments in the technology also. Design energy efficient chemical processes. This is also one of the area where this today's international topic is relevant. Implementation of circular chemistry, that means approach of reuse, recycle and recover. That is again an important parameters. All the researcher must focus on these issues also. Alignment with the global sustainability and environmental goals. Now there are 17 development goals suggested by international community, and all countries are focusing on that all 17 sustainable goals, and we must align with that all sustainable goals and environmental goals, such that all the researcher must focus on these parameters also. There are also importance of advanced materials and nanotechnology nowadays. There are lot of words on that. Design and development of nanostructure material, engineering smarts and functional materials, application of electronics device components and miniaturization, use of sensor. I think chemistry department and physics department of MGV, most of the colleges having a good number of publication on these topics. Role in healthcare, there is a diagnostic drug delivery and biometrics. Relevance to defense applications, I think this is also an important area for the today's topic. Now there are again important in storage systems, innovation in advanced battery technologies. Now this is again for e-vehicles and other storage material. This is again important research area. Development of high performance supercapacitors. Research on hydrogen storage material and systems, design and optimization of fuel cells. Advancement of photovoltaics and solar energy materials. Solution aim at meeting future energy storage and demanding challenges. I think yesterday finance minister declared number of big number of crores of rupees for this all these parameters for Indian development in all these sectors. Catalysis and smart sensing technology, design and advanced catalytic system for an efficient chemical transformation. Development of heterogeneous and homogeneous catalysis. This is also one important area. Lot of researchers are doing very good research on this topic. Emphasis on green sustainable catalysis, creation of high sensitive and selective sensor, applications in environmental monitoring system, that is pollution, water pollution and all different type of pollution. Use of healthcare diagnostic and biosensoring, deployment of industrial safety and process. These are the important topics where all technologists, all research are contributing. And I think most of the papers may be on these topics. Now, bridging the discipline and driving innovations. Nowadays, all the, as per NEP and all the expectation for the all the education authorities that you should work together. That means interactive interdisciplinary researcher must work together, and the area where chemistry, physics, biology and engineering disciplining have a lot of courage on molecular level understanding and structure property, try and design of advanced materials. Data science is the one of the advanced area, AI and computational tool. The material required for this development of this e-materials, what we call it as e-materials, the chemistry can contribute a lot. Now, bridging the discipline and driving innovations, the interdisciplinary coverage of this today's topic, I want to highlight this parameters, smart and functional materials for electronics and sensing, energy and aerospace. Then eco-friendly and sustainable technology, including green materials, low energy process. most of the what I observed as a member of chairman of the board of study, most of the researcher in chemistry are focusing on most of these topics. I think when we observe the PhD topics in the RRC, most of the researcher are focusing on this type of energy materials, sensing materials, then smarts and functional material, eco-friendly and sustainable technology, including green materials. Most of the researcher are giving some ideas on green reactions and lot of different ideas they are focusing. Biomedical and environmental solutions such as drug delivery, diagnostic, water purification, and pollution remediation. This is also one of the a disciplinary area where we must focus. International collaboration further strengthening the impact of the accelerating knowledge translation and global challenging activity. Every researcher must focus on these parameters such that our achievement toward the developments of this country is possible. We can have some figures here for yesterday's budget, Indian Union budgets, and related with the chemicals and material and industrial storage. There is a what we observe at chemical parks. Government trying to three dedicated chemical parks for 600 crores budget is provided. Then carbon capture and utilization and storage, there is near about 20,000 crores budget is allocated for the carbon capture because of the pollution problems and storage and this one. Then 10,000 crore for biopharma Shakti, that is biologies and biosimilar boost. That means they are more focused on the pharmaceutical industry. That means the medical fields, they want to develop some 5 medical hubs in the countries. Then electronics expansion, 40,000 crore for the electronics computer schemes. When the researchers from chemistry or from the electronics, from the physics, whatever we are discussing on these 2 days international conference, we must focus on the budget allocation for the different type of the areas, and that is a chemistry related area is more industrial cluster revival, semiconductor mission 2.0, then capturing good push. That means for this they are also provided the near about 10,000 crores for the development of such type of chemical hubs and semiconductor productions. That means all these related budget are related with our conference, and all researcher must work on the way of the what the government want. Government is more taking more focus on the development of the chemical sector. They want to more production of the chemicals from the India. And for that, what we must focus, all researcher must have some curiosity toward the research on a strong fundamental, ethical and responsible scientific practices. That means when a researcher focus on these parameters, that we should have some ethical and responsible scientific practices, interdisciplinary thinking to solve the complex global problem. Whatever we are doing in research, we must focus on this type of complex problems, that means environmental related or different type of problems. Whatever focusing in the healthcare also, we must focus on this interdisciplinary thinkings and transform idea into a innovation that create a meaningful society and environmental impacts. Whatever we are doing for the communities, and when our research is helpful for the community, then it is possible to develop our countries. Not only publication of the papers and publication of the patents, this is for the only self development, self uh, importance, but we must focus on the development of the countries, develop helpful of the community. Then and then such a practices of research and such a practices of organization of such an international conference will be beneficial. With these few words, I must thank all the organizing committees, respected Principal Nikam sir, Salve sir, and all the those are involved to organize this complex. In this conference, I think a lot of discussion will be there. Moreshar is there, and many more international researchers are there. Dr. Avinash Kumbar also guiding us on this topic also. It is my honor to extend my best wishes for the grand success of this international conference. I wish all the saints great success and enrich outcomes. Thank you for the invitations. Sorry, I have some medical issues. Thank you very much.
Thank you, sir. Thank you so much. Thank you for your and special guidance on Professor Shivutara on the side. It is now my honor to invite our Honorable Chief Guest, Professor Avinash Kumar, sir, from Savitri University, Pune, to deliver of Inaugural. Sir, it's over to you.
एक मिनिट.
Yeah. Hello. Am I audible?
Yes, sir, you are audible.
Great, great.
Hi, sir.
Yes, sir.
One second. Are my slides also visible?
Yes, sir.
Are my slides visible?
Yes, sir. Now it is.
Great, great. Okay. Good morning to one and all. And I would like to first of all congratulate the college for conducting this international conference on frontiers in chemical and material sciences 2026. Principal Adke sir, Principal Nikam sir, and Vice Principal T.S. Savle sir, the convener for this conference. Thank you very much for inviting me. And Principal Jagdale sir, the Chairman BOS, Chemistry, and my colleagues from Chemistry at the college, and those who are attending, like Dr. Sandeep Nahire, R.S. Pawar, and Vishnu Adole, and Dr. Satish Thakre, BOS member, and all the colleagues, and also Moreshwar Chaudhary, who is also a past student of ICER Pune and presently working at the Max Planck Institute, and all my fellow speakers. I see Dr. Santosh Maske, Yogesh More, all are going to speak on important topics in frontiers in chemical and material sciences. And as was rightly pointed out by Professor Jagdale, that a lot of emphasis is going to be there and will be there for materials in the future, and a large amount of money is being funded for many activities that was mentioned. So one of the most important one, or the new change that is taking place, is that funding is coming for materials which are for energy, like carbon capture, utilization and storage, like they call it CCUS, rare earth materials, and also minerals, critical minerals and metals and materials. And I'm sure some of those in the audience who are attending this conference should think and take up projects within this areas. There is going to be a lot of funding available for this, and I'm sure this is one which was pointed out is going to be of national importance. And a lot of work is going on, especially in the case of batteries. Most of us know about batteries and semiconductors. A lot of progress has been done, but one area where progress needs to be done and is being carried out, and many of us can be a part of that, is what I call as is basically hydrogen, or the green hydrogen. So today I'm going to give you just a brief on what green hydrogen is and what researchers can do in this field. So I come from the Department of Chemistry, University of Pune, and if you, I'm sure all of you will agree with me that hydrogen is at the core of life as we know it. Before also we know that it is an energy material, but it is nearly made up of everything that is present in and around us, and is a part of most of the materials that are present, and most of the environment that is present is made up of hydrogen. Now, how we make use of this hydrogen is going to be a very challenging feature, which most of the chemistry researchers should adapt and try to make some contributions in this field for the betterment of living beings. Sir had also mentioned about sustainable development goals. I'm not going to go into all of them, but these sustainable goals is are the our sort of a lighthouse where we have to follow and try to implement these in some of our in terms of, like, for example, clean water and sanitation, okay, affordable and clean energy. The lot of work will be useful, is going to be useful in terms of fuel and energy. And uh, hydrogen plays a very important role in most of these activities. Like, for example, if you take hydrogen production, hydrogen transportation, and its end use, all these are related to some of these goals that are mentioned in as sustainable energy goals. And there is a big research going on in many countries, and in some of the European and in Japan, a lot of hydrogen energy is being utilized for transportation and also for various industries such as steel and other industries to avoid use of carbon and other fuels which are not much present in the Earth's crust. They are diminishing, and so therefore we have to find out an alternate energy for that. So we can get hydrogen from several natural resources. At the moment, people are doing that, but the amount is very less. So the main approaches for green hydrogen production is basically using water as the source, which we say is available in plenty. Unfortunately, not so much in India, but in other countries to a certain extent, yes. And so management of water will also be very important for us. But what is important is that this water, whatever is available, and the sunlight that is available, fortunately in India to a larger extent. So actually, it says that even one day of sunlight and the water that we have, if we can use it appropriately for the generation of hydrogen and oxygen, that will be, and store it later on, that will be enough to carry out most of the activities for 1 year of whole of the country. So this, if that kind of efficiency is obtained, I'm sure this will be a very good fuel that we are looking for. And so therefore green hydrogen using water splitting technology is one of the highly pursued areas in research. And so water splitting that produces hydrogen and oxygen can be carried out by various methods, or electrolysis of water by using electric current, thermochemical water splitting, biological or photobiological water splitting. This is also picking up in terms of using bacteria and enzymes, photoelectrochemical water splitting, and many other techniques that are used are being tried to find out to split water into hydrogen and oxygen, where both of these can be used as fuels or as materials for conversion of simple organic products into more complex organic products as well. So hydrogen is a good source of energy for that. As a chemist, there is a problem in terms of using a conversion of H2O into H2 plus O2 is an energy barrier of 1.23 care of, by preparing materials which will be able to use this band gap either by radiation sources, or either by photolights or by electrochemistry, to convert H2O into H2 and O2. This is possible and this has been done, but what we need is scalability. What we need is how do we improve in terms of the efficiency of this, and also the cost of production, to make it very easily used by common people to a large extent, similar to the photovoltaics and other other energy sources that are being used. There are several challenges in hydrogen production. I will not go into the details of that, which we have to take care of, and I'm sure some of the lectures in this conference will be that, like for example, critical minerals challenges that are there. So there is a less amount of nickel and other noble metals that are present in the earth's crust. So how do we do that? How or can we do it with earth abundant metal ions? Okay, there is also a challenge for renewable sources. There are endogenous resource challenges, right? For example, 1 kg of hydrogen by electrolysis requires about 9 liters of water. So again, we have that water has, so we need to have water as well, okay, for this kind of a production by using green hydrogen. And also we need to have water current global production of water should be good. So these are some of the constraints that we have. However, given the challenge and given the good material that can be produced for this kind of an activity, this is a worthwhile progress. And I'm going to only restrict myself to production by electrolysis and water by photochemistry. So we can use water, using water we can produce green hydrogen by using our knowledge of chemistry, by using materials that are going to be useful for such conversions, because that 1.23 volt energy can be converted or made available by using either transition metal catalysts, and people said about noble metal catalysts, nanostructured materials, which some of or most of the people are working in, carbon based nanomaterials, metal oxide nanoparticles, and single atom catalysts. If these or a combination of these can be used, obviously the energy requirement will be less, the material can be recycled and can be utilized again. So therefore the efficiency of this process will go on increasing, and so therefore this is a worthwhile exercise for the chemists. And I'm just going to give you a few examples of some of the catalysts that are used. So for hydrogen production, presently at a very small scale, but some simple materials such as nickel, cobalt, and iron materials are used for this activity. And I will give you a few examples. So this is basically the how two types of catalysts, as we know, as we teach in chemistry, homogeneous and heterogeneous catalysts that are used. Some of them are acid based catalysts, some of metal complexes, metal based catalysts such as nanoparticles, thin film, three-dimensional structures, and of late the metal organic frameworks, which have become very famous in the last during the last 3-4 months because of the Nobel Prize given to three important, very important scientists. And I'm sure some of our students are also working with these Nobel laureates and metal organic frameworks. And now people are also going to metal free catalysts, because metals are also not very highly present in the earth's crust. Can we use modern techniques or use carbon kind of materials, cellulose, ionic liquids, to avoid the use of metals for this? And so basically hydrogen production methods that are utilized from water need two important material. If it is going to be photochemical, needs a photosensitizer, and two, it needs a catalyst. Okay, so the earth abundant catalysts are the ones that are used in terms of iron, cobalt, and nickel, copper and zinc to a certain extent, but molybdenum, the second and third row transition metals, are not very highly available, but are also used as material for either catalysts or also as photosensitizers. So a combination of this, a sort of a modular system, can be utilized for the conversion of water into hydrogen, both by electrochemistry as well as by photolysis. I will not go directly into the mechanisms of all these, how that can be done, but just give some rough ideas where we can try complexes, metal complexes, which can do this hydrogen generation either photochemically or by electrochemically, or also by chemical methods, A lot of details about how this can be done is given in this reference coordination chemistry reviews. If someone wants to have a look at that, I can share that with them. But one very important idea is that ruthenium based complexes are very good as photosensitizers, and cobalt based systems are good catalysts for doing that. So these two combinations can be done and they can be utilized for hydrogen generation. I will show you three examples for that. Here are some very simple complexes that we have, I mean, that many people have prepared, and our BSc and MSc students also prepare that in the laboratory, called as cobalt dimethyl glyoxime. Okay, this is a very simple complex coordination complex that everyone prepares in the lab. This is one of the best known catalysts that is used for conversion of water into hydrogen in a homogeneous system, and various modifications of this can be done to increase the yield, and a lot of such complexes have been prepared. I will not go into details. There are some nickel complexes also with phosphine based ligands. These are quite exotic ligands that are utilized for preparation conversion of water into hydrogen. And so therefore nickel and cobalt complexes can also be used for this, and so therefore we have done a few couple of studies based on this. I will go directly to that. How that can be done is we at the University of Pune have been synthesizing several cobalt based complexes, and our colleague from ICER, Dr. Bhumi Shankar, had prepared a very interesting cobalt and cobalt complex, which has got 8 cobalt atoms that are present over connected with each other to form a cage. Okay, so we thought that why not use such a cobalt system which is coordinated to water and a very interesting silane based ligand, whether that can do that. So these are the main components: are a photosensitizer, a catalyst, and a bridging ligand. And these are thermodynamically more stable, have got more catalytic sites, and therefore they enhance the efficiency of conversion of water into hydrogen by this by these complexes. So this is the one of the first interested here. We have studied this system in detail in terms of mechanistically. The hydrogen evolved is quite high. We have a small apparatus called as a pressure transducer, which can be used both by a chemical for chemical activation as well as by photochemical activation, as you see in the second picture over here, where you can actually see that we can have light activation as well. We have studied the mechanism of this complex, which can convert because it forms a cobalt hydride complex, and 2 cobalt hydride complexes come together to generate the hydrogen. So this is a good example how it can be done. We have also extended these studies and published these studies in journals. Here is another one which has got a nickel, similar kind of a system, but with a nickel based system, and this can be photocatalyzed to convert water into hydrogen. All the characterizations that can be done, very interesting crystal structure, synthesis and characterizations have been for this have been done, and they also convert water into hydrogen, and we have calculated that the yields may be not very good, but this can be shown that photochemically using a photosensitizer such as ruthenium bipyridine and the nickel based catalyst, you can convert water into hydrogen. A last example I would like to show is something that is based on a modular system which we have done, is that we can design a molecule where a photosensitizer and a catalyst can be connected together. Okay, so if we can connect them together, so we have a modular catalyst, and then this can carry out water oxidation, because as I said, a cobalt dimethyl oxime is the catalyst and the ruthenium trisbipyridine is a photosensitizer. We have made a combination of these two and formed a trinuclear diode assembly where you have 2 rutheniums and 1 cobalt attached to that, and it is exactly the ruthenium absorbs the light. Ruthenium absorbs light, transfers an electron to cobalt to form a cobalt hydride, and this cobalt hydrides combine to form water. The mechanism has been studied. The turnover number, though very less, because we need at least a number which is multiplied by nearly 1 lakh, but still it gives rise to hydrogen. A good fundamental study has been done on this aspect, that homogeneous systems this is a light driven system, so obviously they it can be also done with the help of sunlight, so we don't need much energy for that conversion. But however, the numbers are not very good, but still fundamentally it proves our system. So in short, I would like to say that homogeneous catalyst systems that can be used, they have few advantages, such as they can have tunable properties, good synthesis and education, in terms of education and training students. This is a very good example. This has a very good reactivity. Fundamental understanding of systems can be obtained to enhance into other systems, which would be far better in terms of efficiency, improved kinetics, and low energy requirements. Okay, there are a few limitations, as I mentioned: stability in some cases, scalability, and therefore limits in terms of practical applicability. So these are some of the limitations of this, but this can be sort of eliminated by combining systems, such as combining these catalysts with heterogeneous systems, like in terms of carbon nanotubes or metal organic frameworks. So if we have molecular catalysts with solid supports, we can optimize the electronic properties so that there is a uniform distribution of active sites, so that the efficiency will increase. So these are some of the ideas that I can present to the audience, that they can take this up. I see a lot of metal organic frameworks and carbon nanomaterial people that are working. They are present in the audience, both physically as well as online. So some of these can be taken up to enhance the scalability and also the efficiency of water oxidation and water reduction systems. And simple training can be done with this. So the future is not something that we enter, the future is something that we create. So we have to create an ecosystem where such kind of research will be taken care of for social relevance. Also, this involves a bit of an international collaboration. We have a joint collaboration with University of Stavanger, Norway, and Tohoku University, Japan. About 10 to 12 students have done their on-job training at University of Stavanger, Norway, in some of these aspects. So this also satisfies one of the conditions that is required in NEP of sort of a transnational education. So 10 to 12 students have spent 2 months there, and another batch will be going this summer. So a good example of such a collaboration is also present in this kind of work. And I thank you once again for giving me this opportunity. Hope I have sort of indicated to you what are the areas that people are going to work with and should work with in the near future. And I again take this opportunity to thank the organizers, and I apologize for not being present physically due to some constraints, but I was there about a month back, and I have witnessed a lot of good work that is being taken on in MSG College, and also in Mahatma Gandhi Vidya Mandir's other colleges as well. And I look forward to more interactions in the future. Thank you very much.
And address for molecular homogeneous catalyst for hydrogen generation. Now again, I request to our guest of honor, respected Principal Dr. Harish Arkeder, to address the participants and give his. Thank you. So, Dr. Kumar picture that the homogeneous catalyst hydrogen generation. तर ह्या संदर्भामध्ये मला नाही, पण कॅटलिस्टचा सगळ्या ठिकाणी उपयोग करता होतो आणि खूप महागड आहे. तिकडे पण महागड आहे. पण कॅटलिस्टचा कसा वापर करायचा समाजामध्ये, कसं वागायचं, ते उदाहरण सांगतो. कॅटलिस्टचा जर पाहिलं, कॅटलिस्ट म्हणजे काय, गुंत्याची गुंतलेली गुंता माझा मोकळा, रंगाचे रंगोली रंग माझा मोकळा. याचं जे उदाहरण द्यायचं झालं, त्याचं उदाहरण द्यायचं झालं तर असं असतं की त्या ठिकाणी कॅटलिस्टचा खऱ्या अर्थाने वापर केमिस्ट्रीमध्ये आणि समाजाच्या आत फॅकल्टीला वापर करायचा. तर एका गावामध्ये 3 मुलं, आई वडील होते. आई वडील होते, 3 भाऊ होते. आणि आई वडिलांचे लग्न झाल्यानंतर आई वडील काय म्हटले की आम्ही आता काशीला जातो. काशीला गेल्यानंतर जर मृत वाचू तर परत येऊ. तर नाही म्हणत तर मात्र आमची त्या ठिकाणी त्यांच्याजवळ मी चिठ्ठी देऊ. मी चिठ्ठी देऊन जातो. त्याप्रमाणे हे आई वडील काशीला गेले. 1-2 महिन्यामध्ये हे 3 भाऊ सकाळच्या वेळेला साळवेकरांकडे आले. साळवेकरांकडे आल्याबरोबर साळवेकरांनी पाहिलं की 3 भाऊ आले म्हणजे त्यांचं काही संबंध नाही. बरोबर की नाही? कारण 2 men cannot live in one. बरोबर की नाही? करेक्ट त्यांनी साळवेकरांनी पाहिलं 3 भाऊ एकत्र आले तर त्यांनी लगेच प्रश्नाचं उत्तर सांगून दिलं की तुमचं काही संबंध नाही. 3 भाऊ बोलू लागले काय करणार, त्या बाळाबाळांचं जमत नाही. त्या बाळाबाळांचं जमत नाही म्हणून आम्ही वेगळं भाषेत मग त्यामुळे तुमच्या वडिलांनी मला
स्क्रीनला या स्क्रीनला पण घेऊन का पेन घेऊन का तुम्हाला नेक्स्ट स्लाइड
केलं
लहानाला 1 नाव अति प्रॉपर्टीची म्हणजे त्या गोळ्यांची वाटप करायची. मोठा म्हणजे 1 म्हणजे अर्ध घोडा तर इकडं करता का घोडा मारताय का. आणि वाटते नेहमी तिथे मुलं आहे तुम्हाला उद्या लेक्चर आवडत त्यांच्या आवाज दाखवायचंय तर आता घोडा मग नंतर म्हणे 1 तृतीयांश म्हणजे 3 पावणे का 1 म्हणजे 1.80 घोड्या पण त्या म्हणे आधी तुमच्या वडिलांनी मला काय म्हटलं आता साळवेकर म्हणजे कसा माणूस मदत करणारा पण त्याच्या खिशात हात न घाललेला माणूस. मदत जरूर करणार फक्त बरोबर आणि तो खिशात हात घालणार. मग त्यावेळेला साळवेकर आले म्हणे 3 भावांना म्हणे की तुमच्या वडिलांनी मला काय म्हटलं मी कसा माणूस आहे तुम्हाला मदत करेल पण माझं नुकसान मी करणार नाही पण तुम्हाला मदत करेल. आणि ठीक आहे तुम्ही जा घरी उद्या सकाळी येतो तुमच्या वस्ती उद्या येतो. दुसऱ्या दिवशी साळवेकर स्वतःचा घोडा बाग घेतला घोड्यावर पुढे तुमचे वडील म्हणे सारखा आम्हाला 17 आणि आम्हाला आमच्यासारखे आज येत नाही.